Welcome back. Today we will be talking about Unit 11.5, that is the binomial, and we will deal with the Pascal's triangle. So binomial expansion using the Pascal's triangle, you have been learning about the binomial ever since in middle school. So the Pascal's deals with the triangle. So we create a triangle with 1, 1, and 1. So this third row is generated by adding the 2 from the previous row. So the next row, I can add 1 plus 2, which is 3, 2 plus 1, which is 3. So we have 1, 3, 3, 1. So the idea is with the Pascal's triangle, we start with 1 and we end with 1 always. So I can make the pattern again, 1 plus 3, 3 plus 3, 3 plus 1. And then another layer, 1 plus 4, 4 plus 6, 6 plus 4, and then 4 plus 1. So how it helps? So these Pascal triangles helped us with the binomial expansion, as the name suggests. If I ask you, what is a plus b to the power of 1? The expansion, the coefficient, will be handled with the Pascal's triangle. So a plus b to the power of 0 is 1, but a plus b to the power of 1 will give you the coefficient of a as 1, coefficient of b as 1. That is my second row of the Pascal's triangle. The third row of the Pascal's triangle will help us with the coefficients of a plus b whole squared. A squared has a coefficient of 1, ab has a coefficient of 2, and b squared has a coefficient of 1. That is your third row of the Pascal's triangle, 1, 2, 1. Now, if you look at the third row of the Pascal's triangle, that is the fourth row of the Pascal's triangle, 1, 3, 3, 1. That will give you the pattern, the coefficients of a plus b whole cubed. So that is why the Pascal's triangle helped us to get the coefficients of the binomial expansion. Right? See 1, 2, 1. For a plus b whole cubed, we have 1, 3, 3, 1. So we can understand what coefficients we are looking for. The same way you can, if you want to try, you can try a plus b to the power of 4. And then you will get 1, 4, 6, 6, 4, 1. Now, this is theoretical understanding. By definition, by theory or by theorem, this is what we are looking for. So C0, C1, C2, and so on, all the way to Cn, they are the coefficients and how we are generating the coefficients. Now, the second way of the binomial expansion, it is called using the factorials. We will do a few practice using some problems, but let's understand the theory first. So sometimes the Pascal's triangle is not possible to solve the whole entire, because if the number is too big, maybe a plus b to the power of 20, it is not possible feasibly possible to write all the triangles, all the rows of the Pascal's triangle. So the factorial pattern, it really helps. So nk or nr, it is read as ncr, that is dealing nothing but with the combination. So C is called the combination. So n factorial divided by r factorial times n minus r factorial. So this will help us to get the coefficient of that particular row very easily. So in this example, they are asking for 8c2. That means to the power of 8. If I use the factorial, things will get really easy because 8 is n and r is 2. So I will get 8 factorial divided by 2 factorial times 6 factorial, and I know 6 factorial is contained in 8 factorial only. So I can expand the 8 factorial as 6 factorial times 7 times 8. That will help us to cancel out the 6 factorials, and then we will be left with the answer as, so our answer for 8c2 will be 28. Now the same factorial, but in the bracket format. So 12 is n and 11 is r. So remember, the rhythm is n factorial divided by r factorial times n minus r factorial in the denominator. So if I solve this NCR, I will be just left with 12. So now we know two methods, how to use the factorial and the Pascals. Let's take one example and we will apply both the methods and then you can decide what method works for you. Now it asks for to the power of 5. So I know n to the power of 5. If I have to use the Pascal's triangle, so they are asking for 5, so I need to generate for 5. So this is for the second to the power of 2. This is for to the power of 3. Another for to the power of 4, 1, 4, 6, 4, 1. And then we are generating the row for to the power of 5. 1, 5, 10, 10, 5, 1. So I know the coefficient of to the power of 5 will be 1, 5, 10, 10, 5, 1. Now, let's expand this binomial. Remember, x squared is working as a in this case and 2y is working as b. So we always start with the a with the highest power. So a in this case is x squared with the highest power, which is 5. B with the lowest power is 0. So it is just b to the power of 0. The next coefficient is 5. 5 times a to the power of 4, b to the power of 1. Then 10 times a to the power of 3, b to the power of 2. So a is decreasing, b is increasing in the power. So the next coefficient is 10. So 10 times a to the power of 2, b to the power of 3. Then we have 5 as the coefficient, a to the power of 1, b to the power of 4. And finally, a will reduce, so a to the power of 0, which is just a, which is just 1, and b to the power of 5. So now at this point, we can simplify everything. So the Pascal's triangle, if the power of n is easy to manage and you can write the Pascal's triangle, then it is easier. But the restrictions comes when n to the power of n is very big, maybe 20, 12, or so on. Then at that time, the factorial is a little bit easier to manage. So if you keep on simplifying it further, you should get, remember, a is x squared. So you need to deal with the square. It should be positive 32y, not negative 32y. So this is how we can expand it using Pascal's. Now let's apply the same question using the factorial. Now factorial, the rhythm was NCR, right? So n factorial divided by n r factorial times n minus r factorial. So that factorial will give you the coefficient. So the idea of using the factorial is to get the coefficient. So let's get the coefficient. So the first coefficient will be 5 and 0. That means we are taking 5 highest power of for A and lowest power for B. So that is why I wrote 5, 0. Now the coefficient for the next term will be, the next will be 1. So N will remain 5, but R will increase. R, we will start from 0 all the way to 1, 2, 3, 4, and 5. But A will be to the power of 5, B to the power of 0. Now A will be power to the 4, B to the power of 1. Now 5, 2, because R is increasing to 2. A to the power of 3, B to the power of 2. A is decreasing, B is increasing. Next coefficient will be NR. R in this case will be 3. A to the power of 2, B to the power of 3. Now the next coefficient, it will be 5 and 4, not 3. So it will be 5 and 4, a to the power of 1, b to the power of 4. Then 5 and 5, a to the power of 0, and b to the power of 5. So let me do the corrections. It will be 3, it will be 4 with a to the power of 1 and 5 for a to the power of 0. So now I need to apply the factorial rules to get the coefficients. So factorial rule is n factorial divided by r factorial times n minus r factorial. So 1 factorial times 5 minus 1 factorial. Then x to the power of 8 2y I forgot to write 2. So 5 factorial divided by 2 factorial times 5 minus 2 factorial times x to the power of 6 4y squared. Moving along. Then it will be 8y cubed. Yeah, while writing, I just took y as it is, not with the coefficient of 2. So the next factorial will be 5 and 4. So now I am making the changes. So it was 5, 4 and 5, 5. So 5 factorial divided by 4 factorial times 5 minus 4 factorial x2, and this should be 16y4. And then we can follow along with this. Okay, so yeah, let me make the corrections because I skipped 2 in all my notations. So see, here's the thing. The chances of error will increase if you don't write the factorial well. And then you have to go back and check again. So if the value of n is smaller, I would suggest go for the Pascals, right? So I just made all the corrections now. So the final term, because it is 5 over 5, so 5 factorial divided by 5 factorial times 5 minus 5 factorial. Now x to the power of 0, which is just 1, there is no need to write. And then we have 32 y to the power of 5. Because 2 to the power of 5 is 32. Y to the power of 5. Now let's simplify all the factorials to get our coefficients. Again, be careful. See, I also made the mistake, so it is okay to make mistakes, but correct them. Again, it should be a positive, not negative, yes. So if I simplify it, finally I will get the coefficients. Now, you might say, but on the Pascal's triangle, the coefficients were different. It was a different pattern of the coefficient. Yes, I understand they were different coefficients. The reason is we are getting a little bit increased coefficient because we have b as 2y. So b has the coefficient of 2. That is also playing a role in this, right? So 1, 5, 10, 10, 5, 1. The coefficient is the same. Now let's take another example. In this one, the value of n is 8, but they are just asking for the 5th term. So I don't need all of the terms, but the focus should be on the 5th term. And how we can calculate? Let's get started. So for the 5th term, it implies when r will be 4, right? Then only you are getting to the 5th term, because n is 8 when r is 4. Then we are looking for the fifth term. So 8C4, because we are just looking for the fifth term. There is no need to write the whole entire Pascals. So the factorial will be quite handy. X to the power of n minus r, y, r. Remember, x is a, y is b in this case. So a will decrease, b will increase. So a to the power of 4, 2b to the power of 4. Both of them are 4 in this case. And if you calculate 8 factorial divided by 4 factorial times 8 minus 4 factorial, now a to the power of 4, and that will be 16b4. So for the fifth term, that means the coefficient of the fifth term will be 70. And the whole entire term is 120a4b4, because you are multiplying 70 with 16. But on the if you write the Pascals, the 70 will be the coefficient. All right. So please underline and highlight this equation, NCR times x to the power of n minus r times y to the power of r. So as x decreases, y increases. Now, let's take one more example. So in this case, let's find the coefficient of A4B7. That means A has already reduced, B is increasing, given 3A minus 2B to the power of 11. Now, watch carefully. Now, they want A to the power of 4, B to the power of 7, right? Remember, B started with 0, right? From 0, 1, 2, 3, 4, 5, 6, 7. So let's understand it this way. A is nothing but x. So as 3a is decreasing, y or 2b is increasing, right? X to the power of n minus r, y to the power of r. I know y is to the power of 7, and n is given as 11. So therefore, we can say that b to the power of 7, r is nothing but 7. If I have to apply with the respect to x, the same thing will happen. R will be 7, because a is power to 4. So 11 minus 4 is nothing but 7. Because x n minus r. So 11 minus r, 11 minus what is 4? 11 minus 7 is 4. So r is nothing but 7. So my first goal in this problem was to get the value of r. Okay, now let's move ahead. They want the coefficient when a is to the power of 4 and b is to the power of 7. So let's use the factorial. So remember, we said r is equal to 7, but we are using the factorial as 11c4. Again, in the factorial, I wrote r as 4, but we calculated r as 7. So it should be 11c7. So 11c7 will give you 11 factorial divided by 7 factorial times 4 factorial. So surprisingly, the result will be the same, but I made a mistake. We calculated r as 7, but I wrote r as 4 in 11 in NCR. So just make the correction. And then if you calculate it, finally you will get 8 times 9 times 10 times 11 and times 81 a to the power of 4 times negative 128 b to the power of 7. And in dividing, we have 4 times 3 times 2 times 1. So if you cancel it out, that is the beauty of factorial. We can, do the cross cancellation. So the coefficient of this term will be 330. If you would like, you can go and check on the Pascal's triangle. You will find 330 as the coefficient for the seventh term. And your final answer, when you simplify it everything again, this will be your final answer. Again, in this problem, it should be 11C7 because we just calculated RS7. So be careful when solving all of these questions, and I will see you in the next video. Bye-bye.